Hello, calculus student. This video is for chapter 4.2, differential and linear approximation part 1. And we are going to talk about linear approximation. So what's the goal? The goal is if I have a function, say, graph it, and then it has a formula, right? And I want to find, there's a point, I can find f of a, I plug in f of a, and I find, a number. What happens if I want to plug in something that is not A, but just very close to A? You notice that instead of plugging into the original function, the tangent line that is close to A, so this is A, f of A, that is very close to A is actually very close to the graph because it's tangent to it. When it is really close to A, it's almost the same as f of A. So we use this idea that the tangent line equation actually can be used to approximate f of a plus something. So if there is another point that is very close to a but not exactly a, maybe we'll just, instead of plugging in f of x to get that number, maybe I'll just plug in the tangent line. And we call it linearization or linear approximation. And we also, so this is the tangent line equation. Tangent line equation basically is f of a plus x minus a f prime of a. Why? Because you have been doing tangent line for a long time. So what you do is you will have the point A and f of a, right? And then you say the slope is, this is proving why it's that particular form. The slope of the tangent line is f prime of a. And then we say we use point slope form, right? Point slope form will be y minus y1, y minus f of a is equal to m, which is f prime of a, x minus x1, which is a. So if you just plus f of a on the other side, don't you see that the equation of the tangent line is actually y equal to f of a? We usually don't write it that formal. F prime of a times x minus a. So now usually we would, distribute it and then combine like terms and stuff. No, we're just going to leave it that way. So we say f of x, when x is very close to a, can be approximated by this tangent line equation, f of a plus x minus a f prime of a, because this is actually the tangent line equation of my y equal. So we would write it this way, and we actually would give it a name instead of writing y equal, which would be confused with f of x. We say this is another function called L of x. L of x is actually the tangent line is f of a plus x minus a f prime of a. It's called the linearization approximation of f of x when x is close to a. So let me illustrate with a graph that I have plotted in decimal. So this is a function, negative x squared minus x plus 6. And I want to do a tangent line at point 0, 6 over here, 0, 6. So I put it on and label it. So this is point Q. And it turns out that that particular tangent line is this. You see how when it is very close to Q, this tangent line, I calculated, if we're talking about a point of 0.1 or 0.01, that particular point is so close on the tangent line equation, negative x plus 6, as well as close to f of x. So if I plug in 0.01 and plug in here, they would not be much different. So the idea is, if I want to find f of 0.01, instead of plugging into the original function, I'm going to plug into this tangent line. I will get the same things. Maybe let's try. Let's do this, name it as g of x, okay? And then we would kind of put it here, g of 0.01, what would it be? We have 5.99. If I say f of 0.01, what would it be? 5.9899. They're really close. See the idea? So the idea is, do not use f of x for a point that is close to the tangent line. The tangent line, the 2 points actually the same, but use L of x. Why? Why don't we want a more accurate one? It is because in a tangent line, the equation is simpler. All you need to do is multiply and add something. In the original function, it could be very funky. This one is not too difficult, but it could be sine, cosine, e to the something, so it's difficult to calculate. It takes longer to calculate. So linearization gives us a more efficient way of calculating a function value without using a lot of computer cycle. So that's the idea. We call it linearization. So to do linearization approximation, let's practice doing the linearization of the function at a point. So notice when it is in different point, they have different linearization formula because obviously they would have different tangent line. So let's say if I have a function of y equal to 1 over x squared and I choose a point at a equal to 2, what is the tangent line? So they would ask you for what is L of x, but actually they ask for a tangent line equation. So to do tangent line, first of all, you would do y prime, right? The slope of the tangent line. Y prime would equal to, this would be equal to x to the negative 2. So will be negative 2 x to the negative 3, right? So that means negative 2 over x cubed. And then what do I say? L of x, let's write it out, is equal to f of a. That means f of 2 plus is always like that, x minus a, x minus 2, a is 2. And then f prime of 2. So what do I need? I need f of 2 and f prime of 2. So I have f of 2 this is f, okay? So f of 2 is, I should say this is f of 2. It's f of x. Will be 1 over 4. Okay. F prime of 2 would be the one that we just did. Y prime will be negative 2 over 2 cubed e. So negative 1/4. Okay, so I'm just going to plug it in. So the linearization line that I can use would be f of 2, what was it, 1/4 plus x minus 2, just copy make x minus 2, f prime, negative 1/4. And that is the linearization or the tangent line formula. You don't need to simplify it. Second one, linearization of L of x to this function x sine x. Oh, x sine x is a product rule, right? So what is f prime? So maybe we will do f prime of x would equal to fig and gif, right? Fig g. Fig is a derivative of this times g. So it would be sine x plus gif would be derivative of this times f. Derivative of that is cosine x times x. And then to do linearization, we have to do f of x first, f of a first, which is f of 2 pi. F of 2 pi meaning we plug in here, so sine 2 pi is 0, so everything is 0. We also need f prime of 2 pi. Notice our a is 2 pi. So I would do sine 2 pi is 0, and the cosine 2 pi is 1. 1 time x is 2 pi. So f prime of 2 pi is 2 pi. So what is my L of x? L of x is f of x, f of a is 0, plus x minus a, x minus 2 pi, times f prime of a, which is 2 pi. So you use it to approximate x value when x is close to 2 pi. Now let's do the real one. So we have a function, we have a value that we want to approximate by linearization. So this is square root of 25.1. We know how to do 25 really easily, right? 25 is easy to do, so you should write it down for yourself. And this will give us a hint as to what f of x and what a I want to be. So this a has to be the one that is easy to do is a equal to 25. And what is f of x? What do I do with this 25? I need to do a square root. So my f of x is the square root x. So this is the most important thing because they don't tell you. They just tell you that they want to approximate something that is close to a number. But what number? Well, I would do 25, not 24 because square root of 25 is easy to do. So that is a. So what do we need to do before we write the linearization equation is we need f prime of x first, right? So my f of x is square root of x, so f prime is 1 over 2 square root of x. Because this is x to the 1/2, and then it's negative 1/2. No, it's 1/2 to the x to the negative 1/2, it becomes this. And then we also do f of a, which is a square root of 25 equal to 5, right? And also we need to do f double prime of, no, not double prime, f prime of a. F prime of a is plug in 25 over here. 1 over 2 times 25, square root of 25, I should say, is 1 over 10. Okay, so now we have all these. So we have f prime, f of a, f prime of a. So let's write L of x. L of x is always the original function, which is f of a is 5, plus is always x minus the a that you have, x minus 25. This should be a small number, times the derivative, 1 over 10. Okay, so how do I do L of 25.1? That means I am not plugging into f of square root of 25.1. I'm just plug into the linearization. It will be 5 plus 25.1 minus 25, right? This would be a very small value times 110. So I have a 0.1 times 110. That means 0.01. So it's 5.01. See how I do not even need to use my calculator to do square root, and I know how to do square root of 25.1. It's very powerful. The other one, the next one, do we have enough time to do this? So approximate 30.1 degree by linearization. Obviously, the easy to do one is what? A is 30 degree. When we do a function of sine and cosine, we want to do radian, so it's pi over 6. And what is f of x? F of x would be sine x. Because we're doing sine, they want to do sine. So then we have to do two things, right? F prime of x, actually more than two things, three things. F prime of x, which is cosine x. And then we have to find two values. F of a, f of pi over 6 will be 1/2. That means sine pi over 6. That is equal to 1/2. And then we have to f prime of pi over 6. Oh, we know that this is 3 over 2. So now let's do the linearization formula. The formula would be f of a, which is sine pi over 6, 1/2, plus x minus my a, the a is pi over 6, times f prime of a, which is 3 over 2. Okay, so this is my linear line that I can use to find sine 30.1. But my problem is 30.1 is not radian. So what is 30.1 means? It's actually L of 30.1 is 1.1 degree will be 30 pi over 6 plus 0.1 degree. 0.1 is what? Pi, this is in degree, over 180, right? Plus 0.180. 0.1 plus time pi over 180, that's we convert it into radian. So that would means 1/2 plus, what is pi over 6 plus 0.1 pi over 180? That is just 0.1 pi over 180. Right. And then we times with 3 over 2. Okay, putting it together, 0.5 plus 0.1 times pi over 180 times root 3. It's actually quite difficult, over 2. But you can see that is equal to 0.5015. Sometimes you don't have a scientific calculator. You can use add and subtract and be able to find out what sine of whatever angle it is. So that's how you use linearization. And in the next video, we will do differential.